Let's begin our journey not in the distant future, but right here, in our own time. Today is November 2nd, 2025. The cosmos beckons, and humanity is answering the call. In the next 10 years, we are poised to take some of the most exciting steps in space exploration since we first walked on the moon. We are not just looking up at the stars anymore. We are preparing to go back to them, to touch them, to understand them. Our robotic emissaries are already on their way, scouting the path ahead for us. This is a pivotal decade, a time when our dreams of becoming a spacefaring species begin to take solid form, built on the foundations of science and an unquenchable thirst for discovery. Our near celestial neighbor, the moon, will once again feel the footprint of humanity. Astronauts are preparing for missions to its south pole, a region of tantalizing mystery. This area holds the promise of water ice, tucked away in permanently shadowed craters. This ice is more than just frozen water, it's a vital resource. It can provide drinking water for future lunar inhabitants, oxygen to breathe, and even rocket fuel to propel us further into the solar system. These missions are not just about planting a flag. They are about establishing a foothold, learning to live and work on another world, and turning the moon into a stepping stone to the planets beyond. At the same time, our robotic explorers will venture to worlds that are far more alien. We will send new probes to the searing, toxic environment of Venus, a planet that may have once been like Earth but suffered a runaway greenhouse effect. By studying Venus, we can learn valuable lessons about our own planet's climate and the delicate balance that makes life possible. We will also send missions to Jupiter's icy moon, Europa. Beneath its cracked, frozen shell, scientists believe there is a vast, salty ocean. Could this hidden ocean harbor life? It is one of the most profound questions we can ask, and we are on the cusp of finding the answer. These missions, happening within our own lifetimes, represent the seeds of our future. They are the first, tentative steps on a journey that will span millennia. Every piece of data sent back, every rock sample collected, every challenge overcome by astronauts on the lunar surface, builds the knowledge we need to survive and thrive beyond our home world. We are living in an era of renewed cosmic ambition. The dreams of science fiction are slowly but surely becoming the realities of scientific fact. The next decade is not the end of the story. It is just the beginning of a grand new chapter in the human saga, written across the vast canvas of space. As we project our timeline forward, let's stop a century from now. By the early 22nd century, the tentative steps of our era will have become confident strides. The seeds planted in the next 10 years will have grown into fledgling colonies. The moon will no longer be a place for short visits. It will be a permanent home. Lunar bases bustling with scientists, engineers, and miners will dot the landscape, particularly near the resource-rich poles. These outposts will be marvels of engineering, shielded from radiation and micrometeorites, with enclosed biodomes where crops are grown under artificial light, recycling every drop of water and every breath of air. The moon will become our first off-world industrial and scientific hub. From the established platform of the moon, humanity will make its next great leap to Mars. By the year 2125, the first permanent human settlements will be taking root in the red dust of the fourth planet. These initial Martian habitats will likely be built underground or within lava tubes to protect inhabitants from the thin atmosphere and harsh solar radiation. Early colonists will be pioneers in the truest sense, facing immense challenges but driven by a powerful vision. Their primary job will be survival, but their ultimate goal will be transformation. They will begin the monumental task of terraforming, the process of engineering a planetary environment to be more like Earth's. The dream of a green Mars will drive generations of work. Colonists will deploy machines that release greenhouse gases into the atmosphere, slowly warming the planet and thickening the air. They might steer comets and asteroids rich in water and nitrogen to crash into the surface, delivering the raw materials for oceans and a breathable atmosphere. These are not small undertakings. They are projects, on a scale never before attempted, requiring the coordinated effort of all of humanity. Back on Earth, scientists will work in tandem, developing new technologies and robust ecosystems that can be transported to our new home, all while trying to better manage the climate of our own world. Life on these new worlds will change us. A child born on Mars would grow up under a gravity that is only 38% of Earth's, developing a taller, more slender frame. They would see a pink sky and a small, distant sun. They would know two worlds, the one of their birth and the ancestral home they see as a bright blue star in their night sky. By the end of this first century of expansion, humanity will have become a true multiplanetary species. We will no longer be confined to a single basket. Our survival will be more secure, our perspective broadened, and our destiny forever intertwined with the exploration of the cosmos. Let us journey further, to the year 2500. By this time, humanity's progress is not just measured in distance, but in energy. We may be on the verge of becoming a Type 1 civilization on the Kardashev scale. This is a civilization that has learned to harness all the energy available on its home planet. This includes all the solar energy that falls upon Earth, the geothermal heat from its core, the power of its winds and tides, and the energy locked within atoms. Achieving this status would represent a fundamental shift in our capabilities, unlocking possibilities that seem like magic to us today. It means an end to energy scarcity and a new era of planetary management. As a Type 1 civilization, we would have complete mastery over our planet's systems. We could control the weather, preventing catastrophic storms and distributing rainfall to arid regions. We could stabilize our climate, reversing the damage of previous centuries and creating a global environment of perfect balance. The average human lifespan might extend to 150 years or more, thanks to breakthroughs in medicine and genetic engineering. Cities would be gleaming, efficient metropolises, powered by clean, limitless fusion energy. We would have the power to not only preserve our world but to perfect it, turning Earth into a planetary garden. Out in the solar system, the project to terraform Mars would be reaching its culmination. After centuries of patient work, the red planet might finally be turning blue. The atmosphere would be thick enough for humans to walk on the surface with only a breathing mask. The first Martian rivers would be carving new canyons, and the first oceans would be filling the vast northern lowlands. Hardy, genetically engineered lichen and microbes would be spreading across the land, producing oxygen and creating the first soils. Mars would no longer be a barren outpost. It would be a vibrant, living world, a second home for humanity, with a population in the millions. This mastery of energy would also fuel our continued expansion. Fleets of advanced spacecraft powered by fusion or antimatter would ply the routes between Earth, the Moon, and Mars. The outer solar system, once a distant frontier, would become our backyard. We might even be attempting the even more ambitious project of terraforming Venus, perhaps by building a giant solar shade to cool it down and seeding its atmosphere to break down the thick carbon dioxide clouds. Becoming a Type 1 civilization is not just about power, it's about responsibility. It is the moment humanity graduates from being a passenger on spaceship Earth to becoming its pilot. 1,000,000 years. The number is so vast it's hard to grasp. 1,000,000 years ago, our ancestors were just learning to control fire. What will humanity be 1,000,000 years from now? It's likely we will no longer be human in the way we understand the term today. Evolution, once a slow process driven by natural selection, will be in our own hands. We may merge our biology with our technology, becoming a hybrid species of flesh and machine, a post-human civilization. These beings might be effectively immortal, able to upload their consciousness into new bodies, or exist as pure information in vast computational networks. With such vast timescales and advanced technology, our civilization could achieve the seemingly impossible: becoming a Type 3 civilization. A Type 2 civilization harnesses the power of its star, perhaps by building a Dyson sphere, a megastructure that completely envelops the sun to capture all of its energy output. But a Type 3 civilization is galactic in its scope. It would command the energy of the entire Milky Way galaxy. This means harnessing the light of billions of stars, drawing power from the swirling accretion disks of black holes, and engineering the cosmos on a scale we can barely imagine. Our descendants could become the true masters of our galaxy. A Type 3 civilization would not be confined to one solar system. It would have spread across the galaxy, colonizing countless worlds or living in artificial habitats orbiting untold numbers of stars. Interstellar travel, which seems so daunting to us, would be routine. Perhaps they would use wormholes to fold the fabric of space-time, or travel in ships that approach the speed of light. The Milky Way would be their home, a network of interconnected civilizations spanning 100,000 light-years. They would be the architects of their own destiny, shaping stars and planets to suit their needs, creating art and knowledge on a galactic scale. Yet, even for such a godlike civilization, the universe would still hold mysteries. They would be explorers, pushing the boundaries of knowledge, seeking to understand the fundamental nature of reality, the origin of the universe, and their place within it. They would look for other Type 3 civilizations in neighboring galaxies, searching for peers in the cosmic ocean. The journey of 1,000,000 years transforms us from a fragile species on a single planet to the conscious mind of a galaxy. But the spirit of exploration, the desire to know what lies beyond the next hill, or the next spiral arm, would remain. The quest for knowledge is eternal. Let's wind the clock forward, but this time, let's focus on our home planet. Earth is not a static ball of rock, it is a living, breathing world, and its face is always changing, albeit on a timescale far grander than a human life. 50 million years from now, the map of our world will be unrecognizable. The slow, inexorable march of plate tectonics will have continued its work. Africa will have crashed into Europe, crushing the Mediterranean Sea out of existence and raising a new mountain range. A magnificent chain of peaks that will rival and perhaps even surpass the Himalayas of today. This geological ballet is a constant force, reshaping our planet's surface. 200 million years in the future, this dance of continents will reach a dramatic crescendo. The landmasses of Earth will once again merge, colliding to form a new supercontinent, which some scientists have dubbed Pangaea Proxima. This colossal continent will create a world of extremes. The vast interior will be an immense, scorching desert, far from the moderating influence of any ocean. The coastlines, meanwhile, will be battered by mega monsoons of unimaginable ferocity. Life will be difficult on this future Earth. The formation and breakup of supercontinents are tied to some of the largest mass extinctions in our planet's history, and this one will be no different. Even the heavens above this future Earth will have changed. In about 50 million years, Mars will have a new look. Its small, doomed moon, Phobos, will get too close to the planet. It will cross a boundary known as the Roche limit, the point at which the tidal forces of Mars are stronger than the gravity holding the moon together. Phobos will be torn to shreds. Its fragments will spread out, forming a faint but beautiful ring system around the red planet. Centuries later, Saturn's majestic rings, the jewels of our current solar system, will be gone, having been pulled into the planet by its gravity. The sky is not a constant. It evolves just as the land does. If any descendants of humanity are still on Earth to witness these changes, they will live on a world profoundly different from our own. They would have to be incredibly adaptable to survive the harsh environment of Pangaea Proxima, but perhaps they won't be here. Perhaps they will have long since departed for greener pastures among the stars, leaving Earth to continue its slow, geological waltz alone. Or maybe they will watch from orbit, preserving their ancestral home as a planetary park, a museum of the deep time that shaped them, a silent testament to the planet that gave them birth. Our journey through time is not always a peaceful one. The universe is a dynamic and sometimes violent place. On a long enough timeline, cosmic catastrophes are not a possibility. They are a certainty. 100 million years from now, statistics suggest that Earth is likely to be hit by an asteroid large enough to cause a mass extinction, similar to the one that wiped out the dinosaurs. Such an impact would blot out the sun with debris, plunging the world into a long, dark winter, triggering firestorms and acid rain. For any life on the surface, it would be an apocalypse. However, a future humanity, especially one that has expanded into the solar system, would not be a helpless victim. We would see it coming. With technology far beyond our own, our descendants could have a planetary defense system in place. They could deploy fleets of ships to intercept the threatening asteroid, using advanced propulsion systems to gently nudge it onto a new, harmless trajectory. Or in a more dramatic fashion, they might use focused energy weapons to vaporize it. For a civilization that has mastered its solar system, a dinosaur-killing asteroid is not a threat. It is a routine engineering problem to be solved, but some threats come from much farther away. Stars, the givers of life, can also be destroyers. Within our galactic neighborhood, there are massive stars that will one day end their lives in a supernova, a titanic explosion that can briefly outshine an entire galaxy. Stars like WR-104 or T Pyxidus, thousands of light-years away, are candidates. If one of these were to go supernova and its poles happen to be aimed directly at us, it would unleash a devastating jet of gamma radiation. This gamma ray burst would shred our planet's ozone layer, exposing the surface to deadly ultraviolet radiation from our own sun, and triggering another mass extinction. Surviving a direct hit from a gamma ray burst is a much greater challenge. You cannot nudge a beam of light. A multiplanetary civilization would have a lifeboat. If Earth were sterilized, humanity would live on Mars or in orbital habitats. An even more advanced civilization might be able to construct planetary-scale magnetic shields to deflect the radiation. The universe is full of dangers, from rogue asteroids to exploding stars. The key to long-term survival is not to hide, but to grow, to spread out, and to become advanced enough to foresee the dangers and build the shields necessary to weather the cosmic storms. Let's leap forward in time, to a future so remote it beggars the imagination. 4 billion years from now, the night sky will be a spectacle unlike any we have ever seen. Our home galaxy, the Milky Way, is on a collision course with its nearest large neighbor, the Andromeda Galaxy. They are hurtling toward each other at a speed of over 250,000 miles per hour. As they draw closer, Andromeda will swell in the sky, growing larger and larger until it fills our entire field of view. It will be a majestic, terrifying, and beautiful sight, a cosmic dance of two titans. When the two galaxies finally meet, it will not be a crash in the way we think of one. Galaxies are mostly empty space. The odds of our sun colliding with another star are incredibly small. Instead, the two galaxies will pass through each other like ghosts, but their immense gravitational pull will wreak havoc. The elegant spiral arms of both galaxies will be torn apart, their stars flung out in long, streaming tidal tails. Great clouds of gas and dust will smash into each other, triggering a spectacular burst of star formation, lighting up the merging galaxies with the blue fire of billions of new, young stars. Our solar system will be caught up in this gravitational waltz. We will likely be thrown into a new, completely different orbit. We might be tossed far out into the galactic halo, or perhaps plunged deep into the chaotic, newly forming core of the merged galaxy. The constellations we know will be gone forever, replaced by a new and unfamiliar arrangement of stars. The Milky Way and Andromeda will continue the dance for hundreds of millions of years, passing through each other several times until they finally settle down and merge into a single giant elliptical galaxy, which some astronomers have called Milkomeda. By this point, 4 billion years from now, Earth will be a very different place. It will have long since lost its oceans and atmosphere, but if humanity, or our distant descendants, still exist, they will be witnesses to one of the grandest events in the universe. From their vantage point on a terraformed moon of Jupiter, or from within a self-sufficient space habitat, they will watch the birth of a new galaxy. It is a humbling reminder that even something as vast and seemingly permanent as our Milky Way is just a chapter in a much larger cosmic story, a story of endless change, destruction, and creation. Our story now approaches its unavoidable conclusion, dictated by the life cycle of our own star. 5 billion years from now, the sun will begin to die. Having exhausted the hydrogen fuel in its core, it will start to burn hydrogen in a shell around the core. This change will cause the sun to swell, transforming into a red giant. It will grow larger and larger, its outer layers expanding hundreds of times their current size, engulfing the orbits of the inner planets. Mercury will be the first to go, vaporized by the star's expanding atmosphere. Then Venus will follow, meeting the same fiery end. Earth's fate hangs in the balance. Our planet orbits right on the edge of the sun's predicted maximum size. We might be swallowed whole, or we might survive, charred and tidally locked to the bloated star. But either way, our world will be rendered utterly uninhabitable. Long before the sun's surface reaches us, its intense heat will have boiled away our planet's oceans, stripped away its atmosphere, and baked its surface into a molten slag. The habitable zone, the narrow band of orbital distance where liquid water can exist, will move outward, shifting to the realm of Jupiter and Saturn. Earth's long, beautiful story as a cradle of life will be over. For a civilization that has survived for billions of years, this will not be a surprise. It will be an event foretold by the laws of physics, predicted for eons. They will have had plenty of time to prepare. Perhaps they will have abandoned the inner solar system altogether, relocating their entire civilization to the newly temperate moons of the outer planets. Moons like Europa, Ganymede, or Titan, once frozen worlds, will thaw. Their subsurface oceans will become surface oceans, warmed by the gentle heat of the red giant sun. These could become the new cradles of life, the new homes for our far future descendants. Or perhaps they will have undertaken an engineering project of truly astronomical proportions, moving the Earth itself, using a series of precisely timed gravitational assists from passing asteroids or comets. They could have slowly, painstakingly pushed Earth's orbit outward, keeping it safely within the shifting habitable zone. It is a staggering thought, a civilization with the power to move planets. It shows that with enough time and knowledge, even the death of a star is not an end, but a challenge to be overcome. The final act of our sun will be the ultimate test of our descendants' ingenuity and will to survive. Our epic journey through time comes to an end, but the story of life does not. We have seen humanity evolve from a fragile species on one small planet to a potential galactic intelligence capable of surviving continental shifts, asteroid impacts, and even the death of its own star. The future is a vast open book, and the possibilities are limited only by the laws of physics and our own imagination. The ultimate fate of humanity is not written in the stars. It is to be written by us, and by the descendants, who will follow in our footsteps across the ages. The choices we make today are the first words of that story. As we look out into the cosmos, we see a universe that appears, at first glance, to be sterile and indifferent. But we are the living proof that this is not the whole story. On at least one planet, orbiting at least one star, matter has awakened. The universe has become self-aware. We are the means by which the cosmos can know itself. This is a profound and powerful realization. It gives our fleeting lives meaning and our collective future a purpose. Our destiny may not be just to survive, but to be the carriers of this precious spark of consciousness, to nurture it, and to spread it into the cosmic darkness. Will we be alone on this journey? It seems unlikely. With billions of galaxies, each containing billions of stars, the probability that we are the only thinking beings in the universe is vanishingly small. Perhaps the future of life is not a single story, but a chorus of countless civilizations, each with its own epic journey. Perhaps one day, our descendants will meet them, sharing knowledge and creating a community of life that spans galaxies. The future of life in the universe may be a future of connection, of a cosmos that is not empty, but teeming with thought and wonder. Our journey began with a single step, a look up at the night sky. It ends billions of years from now, with a civilization that has embraced a galaxy. But the spirit remains the same, the spirit of curiosity, of exploration, and of hope. The universe is ancient and we are young. We have an immense future ahead of us, a future filled with challenges and wonders beyond our wildest dreams. The story of life is the greatest story of all, and it has only just begun. The cosmos awaits.